In the xy plane, the graph of a rational function has a hole at x equals -3. The function f also has a slant asymptote with a negative slope. Which of the following could define f of x? So let's take care of step one first. If there's a hole at x equals -3, that means this equation must have an x plus 3 and an x plus 3, one in the numerator, one in the denominator, same multiplicity on both. Okay, I'm not looking at, there's no multiplicity, there's no exponents here at all. So you have an x plus 3 in the numerator, you have an x plus 3 in the denominator, you're good so far. You have an x minus 3, x minus 3, x plus 3, but no x plus 3 up here, so B is out of the question. I'm just going to completely cross that out so I can not have to look at it. Negative x, x plus 3, x minus 6, x plus 3, x minus 9, so you have a possibility. X, x minus 3, x minus 1, x minus 3, x minus 1. So there's no x plus 3s here. You're also out of the question. So it's between A and C. So part one is we took care of the hole at x equals -3. Now what we have to do is try to figure out what the heck it means by having a negative slant asymptote. Well, a slant asymptote that's negative is going to look like this. Also, if it has a slant asymptote, the degree of the polynomial in the numerator has to be 1 more. Now, looking at both of these options, we have x, 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 and we have x, x, so that still works. And we have x, 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 and x, x, so that's still good. So it's not like that's going to eliminate anything. So let's try to kind of draw a picture of what this could possibly look like, knowing that it's not going to be accurate. So it might look something like this, right? And so what am I looking at for a picture like this that has a negative slant asymptote? Well, if I were to look at the end behavior, that might help me figure out which of these will match. The limit as x approaches negative infinity of this guy that I just wrote out, as x approaches negative infinity, it's going up. So it's going to approach positive infinity. When I figure out what the limit as x approaches positive infinity of f of x is, my fake problem, it looks like it's going down and to the right, which means it's approaching negative infinity. So what I need to do is take these guys and figure out which one of these has the end behavior where the negative infinity goes to positive infinity and vice versa on that one. So let's take A and test out A. Now, the way you find the end behavior of something that's all factored out is you take the leading coefficients of each factor and multiply them together. X times x times x is x to the third. Take the leading coefficients of all the factors in the denominator and do the same thing. I almost circled 5 there. Be careful. Don't circle 5. You take that and you simplify that and you get x. Now you take the limit as x approaches positive infinity and the limit as x approaches negative infinity of regular x. Now what that looks like is if you're looking at as x approaches positive infinity of x, you're kind of just like, and I'm doing air quotes that you can't see, plugging in infinity to x, which gives you infinity. And if I'm finding the limit as x approaches negative infinity of x, I'm, air quotes again, plugging in negative infinity for x, and that gives you negative infinity. So with A, the limit as x approaches infinity is infinity. That's the opposite of this. So that is a positive slant asymptote. I don't want A. A is not going to do it. Now let me do B and make sure that it works. Make sure I feel comfortable with it. I have negative x times x times x. So that'll give me, where do I have room? X, negative x cubed on top in the numerator, and x times x on the bottom, so x squared on the bottom. That simplifies out to negative x. So if I were to find the limit as x approaches positive infinity of negative x, I would plug infinity into x, and that gives me negative infinity. Okay. Similarly, if I were to take the limit as x approaches negative infinity of negative x, I would get negative infinity, which becomes positive infinity. And that's exactly what I want. So C is the answer. Okay, so kind of a difficult problem, kind of a challenging problem, But yeah, we used end behavior to figure it out. And it was kind of fun. I had a lot of fun. I hope you did too. Hope this helps.